Hey y'all, it's your math teacher, Mr. Boyden, back at it again today, and we're going to be talking about trigonometric functions today, specifically how to graph them, what the graphs look like, and what the graphs are good for. So we're actually going to start today just by looking at kind of like a visual intro here, because we're going to be talking about trig functions, which are part of a class called periodic functions. And all periodic means is that the functions cyclically repeat. And so we've actually seen stuff that looks like that. For example, what we've looked at that's similar is we've looked at a situation where we go around the unit circle more than one time, and that's why periodic functions are going to relate to our trig functions like sine and cosine. And so I have a basic example here. This is called the electromagnetic spectrum, and all this is, these are different types of rays or radiation that we see in our daily life. Like radio waves, that's how your phone gets internet. Or microwaves, that's how your food gets hot. Visible light, that's how we see. Ultraviolet light, when you walk out in the sun and it feels warm, or if you get sunburn, that's why. X-rays, you probably know what X-rays are used for, or at least one thing X-rays are used for. Like we use those for imaging in medicine. So what about this? This is the stock market. Same sort of deal here, guys, because this starts slow and it swoops up and down, and it kind of goes up and down like a wave. This is the percentage gain in the stock market, so this isn't the prices. I know normally we see a stock chart that kind of ticks up like that. This is going up because it's saying that the average is near 10% for this time interval. And then this one is the tides. This is actually the tides in our local area here in Tacoma, and they go up and down periodically. And it's about once a day that they have two full cycles. So up and down and up and down, and up and down and up and down. And they don't always go to the same height and in the same low each time, but they do have this sort of repeating pattern that shifts a little bit each day. We'll get into graphing these in just a second, but before we do, let's remember what we know about transformations, because that'll be really useful today. So let's take a look at this equation here and see if we can recall what do each of these transformations, or each of these numbers here, do to the graph. Okay, like for example, this pi over 2. That pi over 2 is on the inside of the function. If we can see, it's affecting the x value inside the parentheses, so that would tell us it's a horizontal shift, and since it's negative, that's actually a shift to the right. Okay, what about this 2 right here? That's being added, so that's a shift upward. This negative, that was a vertical reflection because it's multiplying the whole thing by a negative. And then, what about the 3? The 3 is a, well, some people call it like a dilation. I'm going to call it a vertical stretch. Okay, so that'll be useful today. Let's take a look at where the graphs for sine and cosine come from, or maybe why they work the way they do. Okay, so we start out here, we're looking at this sort of unit circle here. Actually, it is a unit circle. It goes from 0 up to 1, so we can see that it is a unit circle. And we see as we track this point around, it goes up and it goes down. Since we're talking about up and down at the moment, let's think about sine, because that's the y values. So when we start over here, and the dot we'll get here in just a second, we start here, we're at a y value of 0. It goes up as high as 1, and then it goes down as low as -1. Now when it gets back over here, pay attention to the direction that the dot is moving. When it gets right here, it's moving up and down, but when it gets up to the top, it's not really moving up and down, it's mostly moving left and right, which is an indication that since it's always changing direction, the graph won't be linear. Okay, let's take a look at what actually happens with the graph. And here comes sine. Okay, so notice this dot over here is showing the height of that dot that was on our circle. It's just recording it going to the right over time. So it goes up and it tracks down, kind of like that wave from the intro, and it goes up and it goes down and back. It's a periodic function because it repeats the same cycle over and over and over. Okay, so things to notice. Just like the unit circle, the highest it goes is up here at 1. The lowest it ever goes is down here at -1. And how long does it take to repeat a whole cycle? From 0 to 2 pi. That makes sense because there's 2 pi radians in one unit circle. And one thing I want you to note, you might want to add this to your notes, the sine function starts at 0 because on the unit circle we start at a y value of 0. Now with that, let's make a prediction. Where does the cosine function start? And to think about that, we say at the beginning of the unit circle here at 0 degrees or 0 radians, what's the cosine value? Well, it's at 1. So let's take a look at this one. And the animation will start over here in just a second. Okay, here it starts at 1, and we're moving to the left. That's why this dot in purple is going down. Once it reaches furthest point left, it's going to start coming back up. Notice the orange dotted line here on both of these. They're the same size. If it's to the right of the axis, it graphs above the y-axis. If it's to the left of the y-axis, it's graphing below the x-axis. So these functionally are the same curve. just one of them is shifted a little bit, or you can think of either of them as being shifted. The cosine curve starts at 1. You might want to make a note of that. It starts high and it goes low, versus the sine starts in the middle and goes up. Now let's go sketch them for ourselves. Now that we see what the graphs look like, I want to show you some tricks to graph them successfully. Okay, so here's what I'm going to do. I remember that sine goes as high as 1 and as low as -1. So I'm going to come and just sort of dot those off, not technically like asymptotes, but kind of functionally a little bit like asymptotes. Okay, then I'm going to come out 1, 2, 3, 4 spaces, and I'm going to label that as 2 pi, the amount for one full cycle, which means that this is pi because that's half as much, and that's pi over 2. I'm going to remember that sine starts in the middle, like at 0, 1, or excuse me, I said it backward. At 1, 0 is our initial coordinates on the unit circle. So remember, sine is that y value. So that starts here. Now we notice it went up and then back and then down. So here's a way we can quickly graph this. The sine function goes from the middle, it goes up to its highest point, then back to the middle, then to its lowest point, then back to the middle. And then we sketch a smooth curve through that. And I'm going to do my best here. It's not going to be too pretty, probably. Not bad. Okay. Now this curve does go both ways. It goes to the right forever, up and down and up and down and up and down. It also goes to the left. Okay, so I'm also going to sketch it to the left. So let's just follow that pattern. So middle, low, middle, high, middle. That means the next one's going to be low, middle, high, middle. I can sketch in this section. And that's the sine function. Now for graphing cosine, very, very similar. Okay, I'm still going to go with 2 pi right here, and pi over 2, and I'm still going to put that dotted line at 1, and the dotted line at -1. This time I think I'll just go to the right with my graph. The only difference is, now, we remember the cosine starts, because that initial coordinate on the unit circle is 1, 0, and cosine is the x value, we're starting our graph at 1. And so it goes high, middle, low, middle, high, middle, low, middle, high. And notice I'm just going over one notch. Now, it is significant that I started all the way over here on 2 pi. I went 1, 2, 3, 4 notches and put 2 pi there, because what I'm doing is I'm coordinating each notch on here with one of these 4 locations on the unit circle, and it turns out that's always going to work for graphing these. Okay, it's a strategy that works for us. So let's graph this. I'm going to do my best here to write on the pad. And how am I doing? I missed a little bit there. Oh well. Okay, so it kind of looks like a W. But again, it's a wave. It goes on forever. There are some key things that we need to know today, and so I'm going to give them to you all at once just so you have the information. That way the rest of what we do makes sense and we have some proper vocabulary. Okay, we already have these basic graphs of sine and cosine, where cosine starts high. There it is. Sine starts low, or excuse me, in the middle and then goes up. Vocabulary-wise, we need to know about the period. The period is the frequency with which the cycle repeats. So it repeats every 2 pi with these basic ones because the unit circle starts over every 2 pi. This little guy right here, it only applies to sine and cosine, but it's going to be important because we need to know the period to graph these, especially if it's not 2 pi. We have a little formula for it. That's 2 pi over b. Please make sure you write that down. What's b? Well, b comes from this right here. Okay, and this is a general form way of writing an equation for sine or cosine. And we have all of our transformations here. We have our vertical shift in D, our horizontal shift. B, we now can see relates to the period of the graph. And A is intentionally called A because it is, and I did these out of order, I guess, but it's called the amplitude. Okay, so we've thought of that as a vertical stretch. Amplitude specifically, and I'm going to label it on the graph here, it's the distance from the midline, and we haven't really talked about that yet. We had the high, I put the line in there, and we had the low, and halfway in between the high and the low is the middle. Okay, and you can't really see it's dotted because it's on the x-axis. But half the distance from the high to low, or the distance from a high to a mid, or from a low to a mid, same thing, that is called the amplitude. The extremes, meaning the max and the min, high points and lows, the maxes are called crests, so this is a crest. The low points are called troughs, so this thing down here is called a trough. Okay, so that's our basics that we're going to use for the rest of today's lesson. Let's try graphing this one. Okay, there's some basic steps that we can go through that'll help us be successful on these. First, I like to start with the period. Period, I remember, equals 2 pi over b, which in this case equals 2 pi divided by pi over 3, that's the number next to x. And then I'm going to flip that up and multiply it, so I get 2 pi times 3 over pi. And that canceled out because I flipped it up. So I have a pi on top and a pi on bottom, and 2 times 3 is 6. That's the period. So remember, we come out 4 notches. 1, 2, 3, 4. We put a 6. 4 more, that'd be 6 more, so 12, which means this is 3, and that's 9. All right, I've got my horizontal axis labeled. Let's do the vertical. Now, normally the function goes from 1 to -1, or -1 to 1, but this one is 5 times bigger. So it goes up to 5 and down to -5. So I'm going to be a little sneaky. I'm just going to call this 5 and that -5. And I'm going to put in my dotted lines. Think of them kind of like as boundaries that will contain the function. Okay, I've taken care of the 5 with my labeling here. I've taken care of the pi over 3 with my labeling here. So I've addressed every part of this function except graphing the sine. So because we've set this up so nicely, all we have to do is remember that sine starts in the middle, and then it goes up, and then it comes to the middle, and then it goes down, and it comes to the middle, and repeat. We put in the dots, then we can sketch the function. Okay. And the sketches don't have to be beautiful, but they do have to represent this key information. Now it's vital that we actually label the axes. If you don't label the axes, you are not demonstrating understanding when you do this. So please clearly label both the x and y axis. Let's try another. If you're feeling good, pause the video and try it on your own. Even if you're not feeling really good, you could probably replicate some of the steps we did in the previous example here before we try it together. Okay, let's do this. Period equals 2 pi over b, which in this case, that's 3, so that'd be 2 pi over 3. So here I go, out to the fourth notch, 2 pi over 3, which means out here, this is 4 pi over 3. All right, what else? Oh, I guess I'll come in here, and maybe this is just 1 pi over 3, and maybe this one's pi over 6 if I want to label it just for fun. We're only going to 1/2 on this one. For me, for my sketch, if I only go here and there, that's a little bit scrunched, and it's actually going to be really hard for me to sketch. So keep in mind, we can label these whatever we want, so long as we're consistent. So I'm going to call this first notch 1/2, and this one -1/2. And let me get rid of the ones I drew in there. I'm going to put in my dotted lines, which, by the way, technically you don't have to do, but I find that it makes it a lot easier to graph them, so I always like to put them in. And I remember that cosine starts high, starts at 1, so I go high, middle, low, middle, high, middle, low, middle, high. Now notice I'm going through the cycle twice. Normally when I teach this, I ask my students to do 2 full cycles, so that's what I'm going to demonstrate in this video today, is going through 2 full cycles, or we now know that cycles are called periods. So I go through 2 full periods on the graph. And there it is. Okay, so notice, not a ton of work to do here. We've represented the 1/2 on the graph. We kind of yes, we technically use an equation here, but that just made labeling the x-axis easy. So we're looking at sine, and really what we're checking to see here is, do we know what that little negative does? Okay, so notice it's on the inside. Take a minute, see if you understand what that does. Pause the video if you need to. You might want to try this one on your own. What we can remember is, since that's on the inside, that represents a horizontal reflection. So let's try the question. Sine goes between -1 and 1, and it hasn't been multiplied. And then the period typically is 2 pi over b, so that would be 2 pi over, and you know what, y'all, it's -1, I get that. Usually we want to say a positive value when we talk about the period, so I'm still going to say this is 2 pi. Recognize -2 pi is still the same distance as pi, so actually it doesn't really matter. Okay, so that's 2 pi, and that would be pi, and that's pi over 2, and I'm going to extend this dot a little bit this way because I'm actually going to go both directions on this graph. Okay, so here's what we understand. Normally, sine starts in the middle, and as we move to the right, it goes up. Well, since it's flipped horizontally, instead of going to the right, we're just going to go to the left. Sine is still going to go up the way it normally does. So normally, sine would look like this. Our sketch is going to go like this. So the reason I'm putting in that dotted line is so you can see that horizontal reflection that I'm doing here. Now once we get the pattern, you just keep it going. So it goes middle, high, middle, low. And then same thing over here. So it goes, I have low, middle, high, middle, low, middle, high, middle, low. And let's do our sketch now. And I should probably complete the cycle on this side and go back to where we started. So that's 2 full cycles now. So when you see a negative in there, no big deal. even though this one looks more challenging, what we're going to do is we're just going to stick to the same principles we've used so far and try to apply them in the exact same way. I'm going to introduce a couple little tricks because there are a few differences here compared to what we've done, but I'm going to show you how to get past those differences. Okay, so let's first pretend like this wasn't here, just for a second. Then it looks very similar to what we've done so far. So let's start by just focusing on this so we don't get overwhelmed, and then we'll come back and uncover that and see what to do about it. Okay, so first things first. Period equals 2 pi over b, which is 2 pi over 4. It's this 4, by the way, not that one. It's the one inside. 2 pi over 4, so that makes this pi over 2. Let's go label that. So 1, 2, 3, 4. That's pi over 2, which means this is pi over 4. And then doubling pi over 2 gives us pi. Okay, that's our first things first. What else? This is a 4, so normally this graph would go as high as 4 and as low as negative 4. So I'm going to make a little note. The high would have been 4, and the low would have been negative 4, but hold on a second, we have this 2 out here. So what we have to do is remember that this 2 is shifting everything up 2. So while the high would have been 4, it got shifted up 2, and now it's 6. The low was negative 4, but because it's being shifted up 2, now it's at negative 2. And then I'm going to introduce something new here that will help us stay organized. So we haven't really talked a ton about it except in that box that we talked about a minute ago. Where's the midline? Well, the mid was between 4 and negative 4. It was the axis. Everything we've done so far has been right on the axis. So that was at 0. That also gets shifted up 2, so now that's at 2. So here's what we do with that. I'm going to label this as 2, 4, 6. And negative 2. So I'm going to put in my high, just like I've been doing. And I'm going to put in my low point down here, just like we've been doing. But now I'm also going to sketch in the midline. Simply because when we say high, middle, low, middle, high, we won't know where to put the mid unless we have that line there. So now that all of this is sketched out, we have support for how to graph this. And now we know cosine starts high. So I go high, middle, low, middle, high, middle, low, middle, high. And that's it. Okay, so that's the only difference. Now that I have this vertical shift, I've introduced a midline, so I understand that I'm not graphing those points on the axis, but I'm graphing them halfway between the high and the low. And then we sketch the same exact way we would have. So, whoops, I went a little bit wide there. So bring it on back in if I can. And if you're in my class, I'm not real picky about how smooth your drawings are. I mean, you can't draw them like absolute value graphs. They need to show that they're curved. A smooth curve or a survivable roller coaster, as we've talked about, okay? You got to hit the points, and you have to label your axes. That's the biggest thing. So really what I'm looking for, a smooth curve that connects points in a correct pattern with labeled axes. That pretty much meets my criteria. Let's start, as we've done on all the examples, by finding the period. Okay, period equals 2 pi over b. So that would be 2 pi over 6, and I'm not saying pi over 6, y'all. I'm saying that this is the 6, so it's always 2 pi over b, recall. Okay, so that simplifies to pi over 3. So that means I go out 1, 2, 3, 4, and that's pi over 3. So that's pi over 6. And then out here we have 2 pi over 3. I'm labeling it just enough so it's clear what my axes are. And then we got to figure out how high is low, and how high is the middle. So I'm going to have my high, I'm going to have my low, and I'm going to have my mid. So let's see, normally the high is 1 and the low is negative 1, but we've multiplied it by 5. So maybe I'll kind of do this in drafts. If I just look at the 5, the new high is at 5 and the new low is at negative 5. But what is this negative 3 doing? This negative 3 is shifting the whole graph down 3. So actually, and the mid would have been 0. So actually, it's all of these minus 3, because that's the shift. So now the new high is 2, and the new mid is negative 3, and the new low is negative 8. Now I've got to be a little creative about how I label my axes now. What I'm going to do is I'm going to label these by 3's. So I'm going to go 3, 6, 9, same thing going down with negatives. So what that would do, that puts negative 8 about in here. That's okay, because all I'm doing is I'm putting a dotted line wherever I think it is. Negative 3 is an easy one, because that's right here. And then 2 is about here. So I'm still able to sketch my high, low, and mid sort of dotted lines in there. All right, so what else have we got to deal with here? I've already dealt with the 6. So actually what I'm going to do, I'm just going to kind of make a note. So I've dealt with that, and I've dealt with that, and I've dealt with that. I have not dealt with that, and I have not dealt with that. All right, so right here we have a vertical reflection. So all that's going to do, sine normally starts in the middle and goes up, it's just going to start in the middle and go down because that's what a flip is. I'm going to come back to this in just a minute. Okay, so right now I'm going to put in a couple points as if I were not knowing what that meant, but I will address it. All right, so what we have now, we're going to start with sine. Sine starts in the middle, and then it goes down, and then it comes back to the mid, and then it goes up high. Now, why am I saying it goes down? Because we said there's a vertical reflection, right? Sine normally goes up, but I'm saying now it goes down. Let's make these a little bigger so they stand out. You say, but wait, Mr. Boyden, you have not dealt with that pi over 6. True that, y'all. So here's the deal with pi over 6. It's inside, so it's dealing in the x direction, left and right. It's being added, which tells us it's a shift to the left. So here's what I got to do. I need to take every one of these points, and I need to shift them pi over 6 units to the left. That's pretty easy because I labeled my axis well and I showed that that's a 6. That tells me that 2 notches is pi over 6. So each dot needs to slide 2 to the left. So, and when I say 2, I don't mean 2 units, I mean 2 of these notches. So here's a new point. And here's a new point, and this one's going to slide 2 to the left, and there's a new point. 2 notches to the left, and there's a new point. And 2 notches to the left, and there's a new point. So now that I have these points, I can play a little game of connect the dots. So connect, and connect, and connect. And so I have now dealt with that shift. And because I've done that, I can still see the pattern. This still goes middle, low, middle, high, middle, which means it's clear to see the next one's going to be low, and then middle, and then high, and then back to the middle. So I can complete 2 full periods of this graph now. And that's it. So that's how I do these. And because what I've tried to do in this video today is kind of build up a progression. We started with the easy ones that just had the amplitude and the period, and then we dealt with some shifts and some flips, and basically you just go through them one at a time. Now the order that works best for me personally is I deal with period first, then I deal with amplitude, then I deal with the vertical, then reflections, then horizontal shifts. Now, there's no magic to that, okay? There's lots of right ways to do this. That's something that I found that works really, really well for my brain and the way I think. If you find something different, awesome. If not, do it my way. Now let's take a look at some applications of what we learned. Okay, here's one example. A sailor on the sea is watching the waves and measures that from their peak they take 8 seconds to fall and rise again, and they're falling 18 feet to their lowest point. And then we get to write a function to model what the sailor is seeing. Okay. The easiest way to break into a question like this one is probably to graph it. So we're starting, maybe I should go like this. From the highest point to the lowest point is 18 feet. Does it say how high the highest point is? Nope, not at all, which means that's totally up to us. In fact, we could start right here and we could go down if we wanted. We could start here and go down if we wanted. It doesn't actually matter because it's all relative. So I'm just going to arbitrarily pick a spot. I'm going to say, I think it starts at 20 and it drops down to 2. Why not? Okay. So guys, you can pick anything you want there. It really doesn't matter. From their peak, they take 8 seconds to fall and rise again. So they fall and they rise again, and that takes 8 seconds. All right, I'm going to make a note. That tells us the period is 8. We're being asked to write a function to model what we're seeing. In order to write the function, it's often easiest to actually see the function first. So here it is, and I've chosen 20 and 2. You could choose something different. That would make your function a little different. But as far as I'm concerned, as long as you do it in a way that's valid, and as long as the equation matches your picture, it's all good with me. Okay? So let's work on writing that function. We need to decide if we think this is a sine or a cosine function. This one goes from high to low to high, so the easy way to write it is as a cosine function, because that's exactly what the cosine function does. We've got a cosine. We need to know the amplitude. One easy way to figure that out, let's include the midline here, because if we know that distance, that would be the amplitude. I need to figure out where the midline is, and the easiest way to do that is to say, what's the average, the middle point, between 20 and 2? So I'll do 20 plus 2 over 2. That's 22 over 2, and so that would be 11. So if this is 11, that would tell me that the amplitude, the distance from here to here, and from here to here, looks like that distance is 9. So I make a note, the amplitude is 9. So I'm going to throw a 9 over here. So I have 9 cosine. I now need to address the period. The period is 8. which we know equals 2 pi over b. So how do I solve that? I'm going to buy myself a little more space down here. 8 equals 2 pi over b. The way I'm going to solve it is I'm going to multiply by b. So I get 8b equals 2 pi, and then I'll divide by 8. So I get b equals pi over 4. So then in here, I get pi over 4. And I'm going to use theta on this one. Oh, actually, I'll use t. It says 8 seconds. I'll use t. So you can use x or theta. I'm going to use t because that matches the question best, and then t would be measured in seconds. Are there any horizontal shifts to deal with? Nope. It starts at its highest point, so there's no horizontal shift. And is there anything that I've missed? Oh yeah, there's a vertical shift on this one. Now, one thing that makes this easy about putting in the midline and the vertical shift are always the same. Because remember, the midline would have been at 0. It's clearly been shifted up 11 units. So I'm just going to put a little plus 11. They asked us to write a function. This is an expression, so I'm going to put height equals. All right, there's a good little equation. Now they ask, generally speaking, when are the waves at the lowest point? So when is that? Let's see. If that's 8, this was 4. So we have 4 seconds right here. When will it be at its low point again? Okay, it goes from low, back to high, back to low. That's having a change every 4 seconds from high to low. So that would be out here at 12 seconds. So it would happen at 4 and at 12, and another 8 seconds would be at 20, and so on. Hey, that's a sequence like we learned in the beginning of the year, isn't it? Okay, so it's going to be at every 8n plus 4. 4 is that starting point. Okay, so that's what, or if you wanted to write it out, you could say starting 4 seconds after the first observation, and then every 8 seconds thereafter, because that's the period. All right, and one more, and we're going to be done for the day. Okay, let's talk about Ferris wheels. And I got a picture of a Ferris wheel for you here. Okay. All right, Ferris wheel has a diameter of 60 feet. The center is 35 feet above the ground, and it completes a revolution every 45 seconds. We need to write an equation that gives the height of the rider above the ground as a function of time. All right, another height question. Interesting. So let's make a graph of the situation. First thing we need to decide is, where does the rider start? Do they start low, middle, or high? And specifically, how high is that? In fact, it dawns on me that I shouldn't probably draw my graph this way, because if I go down like this, that would be showing that the rider goes underground. And looking at this picture in this situation, that rider doesn't ever go underground. So actually, I'm only in quadrant 1. All right, where's the high point on the ride? It has a diameter of 60, but the center is 35 feet above the ground. So that tells me, since the diameter is 60, that tells me this is 30, and this right here is 30. Let's see if another color shows up better. How's that? Hey, that's a little better. So, do I have a better color? And that's 5 down to the ground. So I've got 30, 30, and 5. So that tells me the high point, when I add those together, the high point happens at 65. And if this is 30, and that distance is 5 for a total of 35, then that would tell me that the low point of the ride is at 5, which means the mid, well, that's the center of the ride, right? And they told us right here that's 35. Now, when you get on a Ferris wheel, where do you get on? Usually at the bottom. So my graph is going to start down here, and it's going to create one full cycle going all the way up and all the way back down. That's going to happen every 45 seconds. So I got my mid that goes through here, I've got my high, and I've got my low. Now notice, this is a really rough sketch. It's a plenty good sketch to write out this equation though. Okay, so now we get to decide, do we think this is a sine or a cosine? And honestly, it doesn't really matter. If you want to think of it as a sine that's been shifted to the right, fantastic, that works. Write that equation. If you want to think of this as a cosine that's been flipped, it's like an upside down cosine, that's totally fine too. My personal preference is the upside down cosine, so I'm going to go with negative cosine. Notice I left a space here because I need to include the amplitude. The amplitude, recall, is just this distance, or from the high to the mid, or from the low to the mid, same distance. So that's going to be 30. So I have negative 30 cosine. There's going to be a t in here for time. Again, it's okay to use x or theta, but I'm using t for time. And how do we manipulate that? Let's see. We know from this prompt that the period is 45. So let's see. The period is equal to 2 pi over b. We're looking for b to write it in this equation. Let's multiply by b. So we get 45b equals 2 pi. Divide by 45. And there you go. There's b. Oh, that's a 5, by the way. 5. So then we get 2 pi over 45 times t. Let's see, does that capture everything we have? Not quite. We still need to shift this up from where the midline would have been 0. Now it's up at 35. So what I'm going to do is I'm going to put a 35 right there. That then shifts the function upward. So the height above the ground at any point in time is this equation, 35 minus 30 cosine of 2 pi over 45 times t. So let's try to answer this question. If you were at the bottom of the Ferris wheel 8 seconds ago, how high are you above the ground now? All right, at the bottom of the Ferris wheel, that's 45 seconds. 8, I'm guessing, is somewhere in here. I'm just making a rough guess. And this equation is going to be useful for that because in this equation, 0, based on our graph, represents starting at the bottom. So what we're being told in this question, in sort of a sneaky way though, is that t equals 8. So all we have to do is plug that in our equation. We want h of 8, which is 35 minus 30 cosine of 2 times pi over 45 times 8. And this is totally a calculator exercise. Please do not spend a chunk of your life trying to do this by hand. So I'm going to take a moment here, plug this thing into my calculator. I'm typing it in. You can type it in practice too if you want. It would be a good idea. One thing that we would want to double check before we typed it in the calculator is the mode that we're in. Do we need degrees or radians? Because we're doing 2 pi right here, it seems like we probably need to be in radian mode. So here I go. 35 minus 30 cosine. And then we're going to type in the stuff in the parentheses. So 2 times pi. And I'm going to do it as 2 times pi times 8 divided by 45. And what do I get? I get 21.8. Let's see if that makes sense in context. First of all, can you be 21.8 feet above the ground on a Ferris wheel? Heck yeah, you can. Does it make sense in the context of the picture? So this is saying that this, and I'm just doing a rough sketch, 21.8. Based on my rough sketch, is that reasonable? Yeah, it makes sense. We should not be to the midway point yet because we're not at 22.5 seconds yet. So no, we're not at the midpoint yet. We're still below that. So this makes total sense on the graph and total sense in context. And that's the kind of things we can figure out with this type of math. Hope the video was helpful. Hope you enjoyed it. And we'll see you next time.